it is kind of odd having people not here, whatever. But you're here, and that's all that matters to me. So here's what's going to go on. Today is brought to you by moving forward onto something different. So the something different that we're going to be moving on to is geologic time. Right? So again, we're going to play the game that, I don't know, sometime in like 5th grade, you should have already learned a little bit about fossils and blah, 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 blah. However, if this is the first time you're kind of hearing about this, just so you know, we're going to, today, if you look up on the board where it says biointeractive, this is not going to hurt your computer. It's not going to, I know some of you guys were frustrated when we were doing Google Earth. Do you remember how Google Earth, like you could go here and you could go there? Part of the reason it kind of ended up not hurting your computer, but making your computer go so slow, is just for the fact that it kept on trying to pull in streaming data. So the site that we're going to go to today, it's a static site. So all the data is already uploaded, so it works a lot faster, but it looks like an ancient version of Google Earth. I'm going to ruin the ending for you right now. I'm just going to let you know, in case you want to bring your headphones, or make sure you bring your headphones tomorrow. We have to benchmark. I know you've only had one other class. Did one of your teachers tell you about benchmarking, like last period?
No.
Okay, so here's a fun fact, like on whatever day it was, Saturday, I guess. Mr. Taylor requested that everyone get benchmarked like as soon as possible so that we're not trying to benchmark at the same time that you guys are taking your PSAs and all that kind of stuff. So this is going to be your last chance for me to kind of like see what areas kind of might need some more guidance in or whatnot before you actually take your PSSAs. But understand the, I don't know, randomness that is 8th grade and middle school science ends at the end of this school year. I guarantee you for the next year or 2 years, you're going to get so much more biology than you ever wanted to or asked for. But this is kind of the end of all of that, a little bit of this, a little bit of that. Because after this, we move on to astronomy, which is like totally not really related, other than they're both earth science. So, believe it or not, when you talk about geologic time, we actually have a state fossil. All right, so the trilobite is our state fossil. And I know it looks kind of like a weird piece of messed up candy or something like that, or a piece of poop. But it is a little tiny creature that used to live in the ocean. So if you talk about what Pennsylvania looked like, there's a lot of parts of the United States that don't look the exact same as they did thousands, even millions of years ago. So when you talk about like the fact that we have limestone, right? That's a good indication that we used to look a lot different. But we are not just the United States. So as this plays, I'm asking you, and it doesn't matter if you pick the thing about Pennsylvania, but as this plays, I'm asking you.
Yeah, they're throwing up gang signs over here. I don't know what's happening.
What's up?
They're throwing up like some signs or something like that. They're like right here.
Cool. Okay, so understand as this plays, I'm asking you to think about what parts of the United States have changed and which parts or what they used to look like opposed to what they look like now. Maybe. I mean, that's fancy.
Completely different. But this tour will take you coast to coast, showing you some highlights of how North America took its shape today. Take a look at New York City. Today, it's a grid of streets lined with enormous buildings. But there are strange rocks all over the city, hinting at an earlier, far different landscape. About 450 million years ago, a chain of volcanic islands headed towards the coast, bulldozing mud from the seafloor, and pushing up mountains 10 times taller than any skyscraper in the city. As the mountains eroded away, mud from the sea compressed into Manhattan schist. This bedrock makes strong foundations for the towering skyscrapers that make up this amazing skyline today. Now let's go to the Rocky Mountains. As permanent a fixture as they seem now, these spectacular peaks haven't always been here. Before the Rockies came the ancestral Rocky Mountain Range that dominated the landscape here. Erosion ground these mountains down into sand and pebbles, which were buried and crushed into sandstone slabs. Millions of years later, violent forces pushed up the Rockies version 2.0, lifting and tilting these sandstone slabs sideways. This created the flatirons that can be seen in the foothills of today's Rockies. Nearby in Zion National Park, sandstone forms the sheer walls of the cliffs. That's because this place used to be all sand. The ancestral Rockies disrupted the atmosphere, preventing moisture from reaching this land, transforming it into a vast desert with dunes piled upon dunes. But some of the most surprising clues of the continent's past come from fossils. Here in Kansas, you can find bones of an 80-million-year-old fish that was 14 feet from end to end. So what was a fish doing here in the dry plains of Kansas? 130 million years ago, after the ancestral Rockies had eroded away, oceans flooded the land, creating a vast warm sea that split North America in two. Not far away, at the Kuiperowitz Plateau in Utah, the bones of scores of dinosaurs from this hothouse world have been discovered along what was once the coast of the Inland Sea. The ground reveals not just how life flourished, but also how species died. You may have heard that an asteroid the size of Mount Everest hit the Yucatan Peninsula, laying waste to the dinosaurs. Here in the Badlands, you can actually see the thin, dark layer that contains the telltale evidence of the impact 65 million years ago. Below the line, you can find dinosaur bones. Above it, none. From then on, mammals ruled the continent. Over time, those mammals diversified, and in the La Brea tar pits, bones of giant Ice Age mammals have been found. Woolly mammoths, saber-toothed tigers, and camels, right here in what is now the booming metropolis of Los Angeles. Those Ice Age beasts began to disappear from the continent just as another mammal arrived. Humans began their conquest simply with sharp spears, but have since changed the entire face of the continent, creating structures that rival those built by nature. But our constructions are just as vulnerable as the ones created by nature. Just up the coast at Wallace Creek, the 700-mile-long San Andreas Fault, the boundary between the Pacific and North American plates, is exposed. Tectonic activity is slowly moving this part of the California coast northwards. One day, the drive between LA and San Francisco may be a lot less than 6 hours. This is just one of many places on Earth reminding us that the landscape you see around you today looked different in the past, and will likely look very different again in the future.
So when you talk about Earth's history, there's usually two things people bring up. Either dinosaurs or Pangea, and that's about it. Like, that's the only two things adults usually tell you about geologic time. But understand, dinosaurs are just a small little snippet. So when you talk about what was one geologic change that has occurred in United States geology, oh my gosh. So you talked about you wanted evidence for that asteroid. What color was left in the rock? A lighter or a darker color?
Darker black color.
A darker black color, right? So over here you could say there was a thin black layer for when the asteroid hit Earth. You could say the thing about what state is the San Andreas Fault in?
San Andreas.
California, right? So you could say something about like how the San Andreas Fault line is changing California. We're moving part of California further northward. So whatever sense you put in, that's okay. So understand, and like things like the Rocky Mountains, they've changed in size, but they've definitely been here for quite a while. So here's what I'm going to ask you guys to do or show you. In your Schoology page, if you can click, I'm pretty sure So I want to show you how this works before we worry about like what my expectation is of you, all right? And I will tell you, some people who are like more into, I don't know, online platform stuff, kind of looks a little bit more straightforward. So this thing, and it should say that it's due on Wednesday. If you hit this thing that says Bio Interactive Earth Viewer, so this was put together by, I don't know, I think like 3 different universities in their geology department. So they basically took all their data that they got from fossils and turned it into something that was interactive. Since I can't take you to go visit all these dinosaurs or all these fossils, this site shows you where they are and how it's changed. So do me a favor, if you look at the bottom where it says direct link to the site, if you just click that link first, like that'll take you right to it. Okay? So click, okay, so if you didn't follow directions, if you're in the assignment, you gotta like do 2 extra steps, which is fine. And then just hit a launch thing. So do me a favor, okay guys, if you hit the assignment and hit the link at the very bottom, like go back into Schoology and hit the link at the bottom, it might kind of make your day a little bit easier. So, when your screen looks like mine, you might want to let me give everybody a couple seconds to get there. But appreciate the fact that you can spin it, you can mess with it, you can play with it.
This thing's goofy.
So if you open that bottom.
Bro.
So that's what we just did.
Goofy goober. What are you doing? No. Excuse me. I'm Washington, D.C. Gold. Stop it. Andrew. Andrew. Hey, just go. Hey. I like it cut. Huh?
Thank you.
You said you love me? I'm
No, you aren't.
So here's the thing, as far as what you're able to see, when you spin it around, how many guys have already spun the slant around? Okay, so here's the thing. So before you get seasick, whatever. So.
Yo, what happened? Stop it.
So understand,
Don't gangster.
before you worry about like what this actually shows you, we're gonna talk about how you can actually read it, okay? So right now, if I ask you how much oxygen is in our air, yes or no, is that on your screen?
Yes.
Yes. So shout it out loud and proud. Upper left-hand corner, we got
21%.
21%. Which is crazy, because here's another thing that a lot of adults think. A lot of adults think they've got a lot of oxygen in the air. Right now, if we had like 90% oxygen in the air, if I had a lighter and I lit it, what would happen? Yeah, there'd be a lot of fire. Anytime you plug something in, the whole room would catch on fire. Now, so if you talk about our day, now look up in the upper right-hand corner. Now it's how many hours?
24.
So here's the thing. If you click this bottom part where it says charts, do me a favor, we're going to start with the easy one where it says day length. So down here where it says chart, hit where it says day length.
Whoa, our days are growing.
So what does it mean that our days are growing? That means they're getting wetter.
Longer.
Okay, not being dumb about it, what makes a day?
A year.
Okay, so 24 hours. Well, obviously it wasn't always 24 hours. So think about it. If our day, and I know it looks super dramatic, but this is 22. So they're telling you that a couple million years ago, our whole day was only 21 hours. That means we were spinning a lot wetter. Okay, so that has some consequences to it. So if you look at this trend, that means that our planet's spinning is getting wetter and wetter. Slower and slower. So we need to kind of figure out some large trends. So aside from that, what's another good one? So even if you, let's go with temperature, because there's a nerd fight that
Hey,
people always want to
someone's
get into.
calling you.
Phone call.
Are you Hello?
Quarantine.
Oh, it's okay. It's okay. It's more for like next period. So. Okay. All right. Thanks. Bye.
Bring it on, sister.
Hey.
Alright, it's off topic, but I don't know how not close you right now. Like I sat this far away from her
Bring it on like
No
Donkey
way.
Kong.
for about an hour, yeah.
Bring it on like Donkey Kong.
All right. So here's the thing. As far as temperature goes, understand. Like I know I've told you this before. So I have a granddad who's like in his late 90s, and he like back in the 60s, Time magazine, which is a pretty big magazine. Their whole cover was about how our planet was freezing over, and we were going to go to a big freeze.
I feel it now.
And then in the 90s, like the 90s, early 2000s, it was the exact opposite, and they said our whole planet was doing what?
It's not doing that right now.
getting warmer, right? So now they've just gone into this very generic climate change. So if you look at our temperature, first of all, Fahrenheit or Celsius?
Celsius.
Celsius. So if you follow this trend, right, we are actually, like globally as an average, 14.5 Celsius.
That's cold.
It is half of what it used to be a couple million years ago, okay? However, if you think about 500 million years ago, is there any fossil evidence of a human that old?
No.
No, right?
No.
So understand, we're gonna talk later about how they age fossils. So all of these charts, understand, when you say something like luminosity, what does that mean?
What is that?
How what something is.
Andrew.
Hi.
How bright something is. So do me a favor, hit luminosity.
Actually, never.
100%.
So yet again, here's a very obvious one where our planet over time, when they talk about how bright it is, that is because of our star's evolution, how our star is changing over time.
So we had better stars than they did?
Oh my gosh, how many stars do we have?
A lot.
In our okay, we do have a whole lot in the whole universe. In our solar system, we have how many suns?
What?
One.
In our solar system, we got one sun. In our
Yeah.
universe, there's literally billions.
Really?
Yeah, but I'm just saying, like,
But
since
this is
our
based on
star
us.
level is higher, like, we have better stars.
Good.
Here's the thing, when you talk about being better, just to be honest, in this idea of stellar evolution or how stars change, we have the Goldilocks of stars. If our star was too small, it would have never gotten big enough to even like run through nuclear fusion. If it was too big, it burns really hot and burns itself out pretty quick.
Are there any other planets like Earth?
So they literally, NASA goes through, and I'm not kidding you, they look for what's called the Goldilocks planet.
What the
So they
heck?
do like 5 factors.
Did you just say the
Right?
H word?
They look for a star that's about our same age, but that is not near another star. Then they look for other planets around it. And then they look for whether or not that planet has an atmosphere. And then they look for whether or not that planet has like a regular orbit. And then they look to see about if that orbit is something that is like predictable.
Okay, what if they find one? Find one like Earth.
So far they found about 500
Do it big.
Goldilocks planets.
And beyond.
Right? However, here's the thing. If I tell you, hey, this is really cool, we found out a planet that looks exactly like Earth, that is 10 light years away, that means we're not seeing it the way it is. We're seeing the way it was 10 years ago. Can we travel the speed of light?
I was like, can we travel it?
Light can, we can't. So we have no way to get there, even if we can
And
see it.
beyond.
If you do,
So-
how long would you travel for?
Depends how fast you can go. If you could go the speed of light, it would take you 10
Almost.
years to get there. So if you were like, this is awesome, I can go the speed of light, and you took a picture and then brought that picture back here, 20 years would have passed.
Sheesh.
And most of these stars are a lot further away than that.
That's
So
tubular.
That's fast.
here's
That's
what,
tubular.
so here's what's gonna happen, guys. Right now, do me a favor. On this side, I need you to take this silver bar and slowly scroll it all the way down to the very, 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 very bottom ancient Earth.
Wait, wouldn't that be like time travel pretty much type like that?
Stop talking, Hayden.
Because you go away for 10 years, you come back 20 years later.
What is it? Wait,
That's
what are
not
those
time
things
travel, that's
with
just you going
fires?
really fast.
I'm not trying to be a jerk.
Get
You've
there,
ever
takes you 10
seen-
years to get back.
Yeah.
Stupid.
So
Hey,
if you've ever seen most sci-fi movies, they have a lot of.
I mean, I watched Back to the Future a few times.
So here's the thing. All of this. So I got here because I hit ancient Earth. And now do me a favor, take this little bar and scroll it all the way down.
What, there's still more? What?
What? I
So,
can't do that.
How do you
You're
get
gonna-
Where'd you get more from?
Okay, ready? So over here,
That's cap, it doesn't do that.
it does it in paleo. You need to like click on ancient Earth
I'm heading.
and it'll
You can't
move it
click on
down.
ancient Earth.
It won't let me.
Oh shit!
But I actually have stuff.
Yo, my Earth is like
All the way
apocalypse.
down. Like so highlight
Yo!
over says information.
Yo,
Wait,
Is this
why
like the
yours is
apocalypse, bro?
so weird.
is that how it's gonna be?
Bro,
We're not
this-
gonna be alive, Andrew. Though.
This was the zombies, bruh.
I don't care.
Yo, this was DayZ, bruh.
Yes, it should be.
Yo, this is zombies,
Angie,
bruh.
did you talk to your coach about me being goalie?
No, the other team's goalie
Did you say yes?
sucked.
You definitely said
After
yes.
this home game, the other team's goalie was terrible. She literally let the ball roll in between her
Oh,
legs.
you were the Shippensburg, yeah.
She literally let the ball roll in between her legs.
Mr. Matt wouldn't even said to you guys. Was he really?
As far as I can go.
I literally came out the wrong cut, but you guys getting kicked out.
Brady and Connor came back. Brady and Connor came back.
Hey guys, do you guys have to double click?
Brady and
again?
Connor came back.
I did. I clicked actually many times.
I'm perfect.
Can I go to the bathroom, Fire?
Scar? I got an RPG shooting rockets. Gonna make it sound like that.
You're gonna come to our game again
Tuesday.
Alright, so
Tuesday.
here's the thing.
Tomorrow, you
Oh, man.
Tomorrow.
When you talk about why it looks all red,
mean? I should have picked up on this platform.
What'd you do?
We're down on the field.
Got
It's
an
hard to pick those
RPG
before they
shooting
were up.
rockets.
An hour and a half is what we came down.
He literally came down and just kicked you guys
That
out.
was all me. I don't even know why.
Doesn't that suck? Loser.
right? Let's go around.
Yeah.
Okay. Okay. So here's the thing. When you talk about what it used to look like, that used to look like if you think about this is an MYA. So MYA, you need to learn, stands for millions. What does R probably stand for?
Billion. Wait, what'd you say?
What's MYA? So the M is millions, the Y
Years ago.
years, and then the A is a go. So here,
So everyone's gotta be dead, pretty much. That's what happened.
A go in the past, you
Right.
dingus.
so help me out. Where it says informational down here, if there was somebody or somebody that decided to time travel down to this very, very early Earth, they would have just simply been what?
Gone.
Like eviscerated, right? There's nothing left. Yeah. So, do me a favor. Move it up until you see water, okay?
What the?
You would either burn alive or suffocate.
Yeah, pretty much. So, just until you see a little bit of like something like this, it doesn't matter if it's not the exact same time.
112,000 ppm.
So, here's the thing. That means that there's a lot of carbon dioxide in the air. If you were like, oh my gosh, there's a cute little volcanic island. I want to live there. I'm going to go time travel and go on that island. You would die because there is no wet in the air.
Oxygen.
Oxygen, right? So do me a favor, keep on going up a little bit until you start to see oxygen, okay? So keep going until you see
0.1.
So once this gets above 0, then what happened to Earth?
Livable.
It turned what color?
I knew you were liberal.
So when you talk about what that might be, it might be a phone call.
Trees. Trees. The thing is trees.
You've been quarantined. What are those? Yeah.
I'm not misleading like that. I'll smack you.
It's legal.
I had this legal.
I mean, it is one of those things that I just don't want something else as well.
It could be Mr. Taylor.
Everybody's just gonna
Hey! So, help me out, guys. If you think about, guys, so if you think about the temperature, that probably means that our global temperature did what?
Heat. Cold.
Plummeted, right? So we went from a lava planet to this. So when you talk about being a lava planet, appreciate the fact that we have had snowball Earth time periods.
Barclay Shores.
Do me a favor. Where it says in depth, oh, just kidding. Hold on. Where it says view,
Wait, but you went past the other 1.1. There's like a lower 1.1.
There's no point one.
where it just kind of like pops up real quick. Even if you pick that one, we still got the same issue.
No, lower. Like it's just water.
She's not looking for just water.
It's a really big.
She's looking for
Like
oxygen.
look at mine.
Oh, yeah, no, I get what you're saying, yeah. So I'm saying find the one where it pops up with the first snowball planet, okay? So, do me a favor. On this, can you click, so I click view, even if you're in the wrong spot, or like not in the exact same right millions of years? right now, click where it says geologic events.
Wait, what?
So I hit view.
Yeah.
So if you hit geologic events,
Yeah.
It comes out.
Everybody get up. Oh, stop doing gang signs.
see, there's no gang signs.
Wait, isn't it his birthday?
Oh,
Yeah, I don't
Yeah, it
care.
is Charlie's birthday.
Yeah, I don't care.
It's very rude.
Yeah, I still don't care. Are you cold?
This is why you're cold. Cold. Can't even afford heat.
then what the?
So when you check that off, and if it bugs you right now, if you want to check off where it says grid lines, you can really see it. Everyone, what's your last name?
Klein.
Klein, okay, this is Miss Klein. Miss Klein said, if you didn't realize, Miss Brown's not here. So Miss Klein, if you want to kind of like watch what we're doing, and if you have any questions, feel free to ask.
I had something.
Yeah, you can just
I have
go
a
sit at
question.
table 6, like that white table.
I had something that something cool came
There
out.
you go.
I had something that something cool came out.
Right, so here's the thing, guys. Right now, when you click geologic events, you should have all these little arrows pop up. So hit any arrow, and a little screen should pop up that give you some more information. Okay?
Oh, great. Oh,
So do me a favor right now, guys.
It won't go.
Click. I don't care if you hit Snowball Earth or hit one of those triangles, but let me know if you can't find those triangles.
I can't
Okay,
find that.
so click one of those. Thank you. Guys, you gotta get rid of the view thing, and then
I'm usually
one of those.
I am. I like to.
It won't
Yeah.
like that.
Cold. Yeah.
Ask for Andy.
My name is.
Let me try it. Let me try it.
I like to run.
We took a bunch from Mr. Brother's desk.
Why?
Oh,
Guys, seriously,
they're little kids' masks.
what? I'm just being honest, we don't have enough of them.
The little kids' masks.
Enough, period. That's where we ended up getting them. So if you can
I'm gonna
go
get
in
like
there. 4
of them on the back of his desk. Gonna read a bunch of math books.
So I have.
All right, anyone else now get to the little triangles?
Why is
I
that?
finally got there.
Triangles, triangles. Your little triangles.
So weird.
How about
Cold.
Alright, so you got
And you get good.
Alright, so here's what's gonna happen. If you can go, this stuff, all of this stuff right here is literally so ancient that it is very hard to find geological evidence of what went on during that time. So when we say geologic time, most of this we don't really talk about because there wasn't really anything living on Earth, and most of Earth was just kind of starting something of a supercontinent. We just started to get land masses.
Wait, we're in the past?
No, we're in the present future.
I thought we were in the future this whole time.
How? I'm not trying to help. That is why when I asked you what MYA stood for, right here, this is how you know how long ago it was, right? So always kind of keep track of your, like, I don't know, time ruler, I guess.
Yeah.
So,
That's it, though.
do me a favor. Click where it says paleo. Most of what you're going to do is in the paleo, okay? When you talk about right up here, though, by the 0, when you look at the Ice Age, this is now thousands of years ago. And then the warming Earth, do me a favor, hit that very top one, warming Earth.
Where do you?
All the way at the very, very top.
Mine looks weird.
So,
Yo, it's a golden Earth, bruh.
so if you talk about
Yo,
the golden
shut up.
part of it, do me a favor, guys. Put your cursor right here between 2002 and 2012. When you look at the planet,
I think it's so orange.
well, now here's the thing. Here's what you need to understand. Stop. Are you kidding me? No. Don't do that. So if you look at those colors, if the whole planet every single year was warming up, look at that little key. You want to see orange. What's like the top warmest color they give you?
Red.
2, which is a red, right? So if our planet truly was totally, as a planet, experienced global warming, the whole planet would be this color. People kind of worry because the warmest part, what should be up here? A whole bunch of
Cold ice.
like ice, right? Because it's supposed to be cold. That's what they worry about. If you look at the oceans, a lot of the oceans are staying about the what?
Cold and warm.
Yeah, either a little bit of warm or cold. And the part that it is kind of good, interesting, whatever, that there is one part of Antarctica that is staying exceptionally cold.
What part is that?
That one little sliver, right? That's turning blue.
Is it still gonna be like right now?
So when you talk about right now, it goes up to 2012, I think, yeah.
That's blue.
Well, I will tell you, this takes a long time to generate this data, right?
Oh.
So here's what I'm going to ask you to do. Now that you all have, I did that.
1912 is just.
So now that we all have like the basic idea of how this works, do me a favor and open up the actual assignment in Schoology, okay? So Rose, if you want to open up your assignment. And then I'll try as well. So, what's wrong? No, it is pretty cold down there, from back there. All right,
Kendall's fine. She's a girl.
Here's the sweatshirt.
why do you have to open up your mouth? All right, so here's the thing. As far as, ready? So as far as what we did do, guys, I walked through part of this with you just to make sure we could all be on the same page. So number one will actually take you to where this information like sits on the internet that gives you all the research behind how they made this model. For number two, where it says on the top of the globe, what are the 4 pieces of data that change as you move the silver pointer? So I gave you A. Help me out for B. It says atmospheric. Which one is in percentages?
Oxygen.
Okay, so here's the thing. I don't care if you write O2 or write out oxygen. Both would be correct. So for this one, you can write in oxygen.
No, my crumble.
Cool start. Or you can write O with a little tiny 2. Okay?
Oxygen.
So right there, you can either write in oxygen.
It died.
No, shut up. I just watched the screen go white. And shut up. Shut up, you fool. And charge. Keep charge.
All right. So here's the difference, guys. You breathe in. When it says O2, you breathe 2 oxygen in that are stuck together, right? If I gave you pure oxygen, your body would actually have trouble breathing it in. If I gave you 3 oxygens glued together, it would actually hurt your lungs, and that's called ozone. It's really good up in the air, not right here. All right, help me out. The ppm stands for parts per million. So you tell me which thing is in parts per billion or parts per million? Go. What's CO2 stand for? Carbon dioxide. So do me a favor right now. Right here, Z's. You're gonna write in it's okay, guys. You're gonna write in carbon dioxide.
It's okay, something happened to me.
Did your computer shut? You all right?
No.
Is it gonna be charged?
No, it's fully charged.
Okay. All right. So the last one. So that one's gonna be carbon dioxide. So carbon dioxide is what you now breathe. What, in or out?
Out.
Out. So for the last one, when it talks about our days, so for part number D, it's giving you the what of that day, what it is,
Hours.
how long it is and they count it by what?
Hours.
Hours. So here, you're going to put the word length
An hour.
and then hours. Very good.
If you think about
So you're going to say the day's length in hours. All right, so for some of this, I fully appreciate the fact that some of this it is kind of easier if I'm up here showing you the directions and you can kind of do it on your screen, okay? So for step number 3, or item number 3, so you're gonna go on the far left, and it's what we were doing a couple minutes ago. So you're gonna click where it says Ancient Earth to view the earliest evidence of our geologic record. So click on the following locations and describe what the land changed, or how the land's changed when you spin the globe. So this, you do not specifically have to find me a little triangle.
What I'm for this?
We're gonna put in discussion. Oh, gosh, carbon dioxide. All right, so do me a favor. Since we were all just here, when you clicked on that informational, you guys all said it looked what color? Why was it all red? What was that supposed to be?
Heat.
Heat, lava, right? So for A, you can just say molten earth, or earth was all magma. Something to describe why it was all red. So for 3A, you can say there was all lava, it was all made out of magma, it was a molten earth. The whole point being, if you were to time travel, I would not pick this time period.
Why are you just saying that?
It's kind of nice to have all people,
So-
not that much.
When you talk about the Archean eon, think about a cat. I just want to tell you right now, when you see words like eon and era, think about a calendar, all right? So right now, if I, like the calendar that's on the bulletin board, if I ripped off pages, I'm ripping off entire what's of that calendar.
Lights.
They're entire months. If I cross out an entire row, that's an entire what?
Weed.
Week. And if I put one little X, then I'm just talking about,
Day.
okay. The same way that we organize a calendar, we do the same thing when we deal with geologic time. The eons are like our months. The eras are like our weeks. And then when you talk about the time periods, which we'll get to later, those are like our days. So we have to go to this one, right? So the Archean, so if you go to Ancient Earth, and I want to ask you to start here. So it gives you something about, so it says the Archean Aeon, about 2.5 billion years ago, Earth had so when they talk about anoxic atmosphere, that means we didn't have any what in it?
Oxygen.
Oxygen. But we did have a lot of carbon dioxide that would be toxic to most life on the planet today. During that time, Earth's continental crust began to accumulate, and the first evidence of life was found. Help me out. Look on this whole stinking thing. That life was probably in the water or on land.
Water.
Definitely in water, okay? Well, so, do me a favor though. If you scroll up through this, most of it, when there was land, what's the one color that you saw?
Red.
That's not red.
Orange.
Like an orangish color, right?
Orange.
So help me out.
Red.
You're goofy.
This whole sad early supercontinent, does it look like it had mountains?
Pangea.
No. Does it look like it had vegetation?
Pangea.
Not so much, right? So do me a favor, describe what you see for 3D.
Oh, bad one.
I did.
14.
Yeah, sure.
Stop.
Hey Lou, the guidance needs to talk to you about course selection stuff. If you just want to, you're only probably going to be a second.
Go in there. Tell her
All
I
right,
did not do anything.
she's in the guidance.
Joe.
All right. You better have done something with course selection. All right, so for this, so right now for 3B, you're going to describe what you see here. You can say most of the planet was made of what?
Magma.
Say it.
What's the blue stuff?
Water.
Water. And then the land, I don't care if you say the land was flat or the land didn't have any vegetation. Don't tell me the land looks sad, because that's an opinion.
It's really sad though.
It is kind of sad.
But
Oh, it's
some of
pretty.
the work is mostly water and had some flat land.
That means the days are spinning faster.
So we were spinning a whole lot faster, right? Because our day was only 18 hours.
Does that mean our
We're
Earth
almost
slowed
like-
down?
So part of that has to do with the fact that of our moon going away from us. So our moon is one thing that helps keep our planet in a very regular orbit.
You
So
said
the
you're
further
away
away
from
our
us.
moon gets from us,
That's not
the
nice.
the smaller our tides are going to be. Yes, ma'am.
Wait, how did land grow? It was all water.
So if you back here,
Can we just go
Shut up.
you tell me what's starting to happen a little bit.
Volcano.
Okay.
Yeah. So when you talk about how it went from being like completely frozen, that's a little bit further up. So this, the water that was there, the magma had to first do what?
Melted.
It was really, really hot, right? It had to do what a little bit?
Heat it. Something.
Cool, right? So if you think about it cooling, all that water from like little tiny asteroids and stuff like that hitting it is how we got some water, not super deep though. And then anytime you did have volcanic action, it kind of started rising up above the surface.
Oh, but then how the volcano get there then?
Because it's
Because
gangster
you
like
got
that.
one.
Well, if everything, the entire
Yes,
earth was
that's
water, first president.
So all the way back here, right? You remember how we started all super hot, right?
Yeah.
Then we got to cool a little bit. So when you talk about like, I don't know if you guys ever seen pictures of the moon, but like, yeah, it very much looks like the moon, right?
For real, for real.
So we're kind of like nothing really there, and it's the same as you walking on lava that is just cooled. Like if you were to step on this, you'd probably do what?
Sink.
Like sink right through, right? The crust is there,
It's like hard
not
rocks.
super
From
thick yet, yeah? So then that water starts to accumulate just because we had no real atmosphere. So we're hit by thousands and thousands of little tiny asteroids or meteors, and they all have water on them. And besides that, as this stuff cools, the water also comes out of it. So there's two ways we get water. Then we got some water, and then little volcanoes pop out of it where there's just more activity. Just even now, right, inside of our Earth, there's certain spots where there's volcanic action, but it's not going to be out my window,
So
right?
are they
Yeah.
islands or just giant volcanoes?
Both. Yep, they're giant volcanic islands, and that's about it, right? So even if you were going to try to like time travel right there, probably not very hospitable. All right, so now for whatever this is, 3C, where it says the very beginning of the Paleo-Preozoic era in the Proterozoic era. I stink. This is like the dyslexic unit. All right, so they're at the very beginning, paleo just means that it's something really, really old. Oh, hold on one second. Sorry.
I got it. I got
You know where I can go with it.
it. Stop it, Terrence.
You want smack
He's
in
so
your face
ugly.
with your guests.
Okay, this got worse, I swear.
Sit down.
We got one.
So if you go to the Paleo-Preozoic era, so on here, so we're right here-ish. Let me make sure I'm in the right
This
spot.
one needs.
So the very beginning of that, which would be right. So I'm about right here.
One little white.
Oh, that's the snow age.
So if you talk about, this is not the same as the Ice Age. This is what literally they call our planet. Do you remember the name of it?
Snow.
Think about
Snowball.
chucking a piece of snow at somebody.
Snowball.
Yeah, snowball planet.
White.
So do me a favor for this one. You can say Earth. So Earth was one giant snowball, or snowball Earth. But the point is, it did not last very long, but we are talking the whole stinking thing.
So hard to undo it.
So when you talk about the whole stinking thing, we had some cute little volcanic islands that were there that are now just covered with ice. But if you, as you move this thing up, you should be able to tell it did not last. It did not last very long. So I want to recenter this. All right. So the next one, now we're going to go the Meso. So Meso means middle. So the Mesoproterozoic era. So now we went from the early Prozoic. Now we're going to the middle. So I'm going to move this. Okay, just say the middle or the beginning of it. It didn't say. So in the Meso, if you can watch my screen if you want to. If you watch my screen during that whole time, what looks like it's dominating Earth? Land or water?
Water.
Okay, so even if I do find a cute little bit of land, as I move forward in time, that land doesn't really even look like it's coming together or going apart. They're kind of going apart, but it's not anything nearly as dramatic as Pangea. Still though, when you say sad, what's true about that land? Do we got any vegetation?
No.
No.
No. Do we have any mountains?
No.
No.
Do we have any heat? No.
Fair enough. So to answer this, so for, what is this D? What is this? For D, you can say mostly water with small, flat continents. So mostly water with small, flat continents. All right, Andy, what was your question?
How do you know you'd even the continents of it? So how like would it after the year pass by how would it break apart? The water and like the water getting smaller and smaller.
So here's the thing.
If you think about it from
When you-
outside,
Ready, guys? So when you look at this part right here, why is that light blue? What's true about the depth?
it's deep. Oh wait, on the sides it's
Shallow.
Shallow, right?
and on the darker ones it's deeper.
So this is the first time that we're starting to get different colors of blue, and that makes a difference. We got this light blue, and then right next to it just kind of drops off. So this is the first time that we're kind of starting to get shelves. So I don't know if have you guys ever gone in a boat on the ocean?
No,
Yeah.
yeah.
Have any of you ever gone fishing in the ocean?
Yeah.
Okay. So I will tell you, this right here is where most people go fishing. Like when they say they're fishing out in the open ocean, they're not like fishing out in the middle of the Pacific. They're on what's called the continental shelf. So this is the beginning of our continental shelves, or our continents kind of having an edge to them or a side. So now Neo, so you got Paleo, ancient, Meso, middle, Neo is kind of like self-explanatory. That's the water stuff, the new stuff. So the Neo-Prozoic, if you go, up here's these. So now we're between 1,000 and 500. So if you watch my screen, we go from being very, very dark
And vegetation.
and some vegetation to then we all turn into a what? Snowball. To then we went back to having
So dark.
some vegetation. But watch my screen for a sec, guys. Look at where I'm going to. Where's most of the land?
And the
South.
equator.
Most of it's down in the South Pole, which is kind of messed up to think about. Some of our earliest continents were there, whereas if you look at the North Pole, we had some ice, and then on the other side of the planet, we had Pangea. So this is the United States. Like right now, United States would be right here.
Cap. It's not like
If I spin it, you can see how most of like ancient Pangea, most of it was over the Antarctic, and some of it kind of came up all the way to the North Pole. So if you talk about what we're going to see now, let's start with the water. Most of the ocean is very what?
deep.
Very deep, right? So we can say one ocean that is very deep with land. Oh my goodness. What's the green stuff? Vegetation. With vegetation, yeah? So one deep ocean and land that has vegetation.
What do they call it?
I throw dinks on it. Somebody dinks it.
So, I don't know if you want to call it one peninsula or one big island, but it's pretty much like we're one big island, right? So, appreciate the fact that I have my cities checked off. So, I just want to, just for the sake of helping you out, if I spin this, Hawaii is just kind of always where Hawaii is. South Pole That's where Los Angeles used to be. If you talk about some other cities,
Washington D.C.
you got Chicago, New York, Toronto, all those land masses that are now well above the equator started off all the way down by the Antarctica.
Well,
right?
couldn't they like came from the south and like circled around the top, like yeah, like about the backside?
So here's the thing. There's not a lot of geologic activity up here, like plate tectonic activity, to get it to move,
The Earth is flat.
right? What did help move it a lot more was all the activity at the bottom, or the South Pole, that helped kind of shove it up. All right, so now that we got number 3, for number, is that number, yes. All right,
4.
so now for number 4. So now we're going to click on the Paleo-Earth section to open up what's called the Phanerozoic Eon. So we're literally tearing off one whole page of the calendar. So the Phanerozoic Eon is honestly the one that most people care about. Everything that we just did, people usually just lump it into what's called the Hayden period, and that's it.
That's my name.
I will tell you, it actually comes from Hades. So like those of you that remember anything about mythology, it comes from Hades, who was a god of what?
This
The underworld, right?
Underworld.
The god of the underworld.
Well, I will tell you, my last name used to be Hade. So my last name, when there was more than one of me, was Hades. So nothing was better than walking in and pulled out like we're all devils. So do me a favor. You're going to hit the Phanerozoic Eon and move the silver bar to the top of the yellow section. In the Cenozoic, and I'm going to show you how to do it in a sec. So in the Cenozoic era, in the quarantine period, where it says 0 MA, what are the current conditions? So, let me help you out. So on here, we're going to go to Paleo-Earth.
Whoa.
So I'm going to slide this.
Wait, what? I thought we said at the yellow. He said.
Did I?
It said yellow. Yellow section.
Yes.
Move the silver up to the top of the yellow section, the Cenozoic era, you're right. In the quarantine period, blah, blah, blah. Okay. So, right now, you're going to take this and move it all the way up to where it says 0. That's what?
That's all you have to do.
That's right.
No.
Now, okay? So, understand, when you hit Ice Age and you hit warming Earth, that's not you traveling into the future. That's them just taking the calendar and expanding it or giving you more details. So now, when you look at this screen, you're going to do the same thing. Millions of years ago means it's right now. Our percent oxygen, you're going to put in as what? 21%? This is number 4, right?
Yeah.
Okay. So do me a favor, guys, for question number 4, so make sure you're on question number 4, and then for part B, for the oxygen, can you put in 21%?
Then 9. 2.
And then for the next one over where it says CO2, what's that say?
392.
392? Bless you. And understand, 392 is not bad. Like, it used to be in the hundreds of thousands. And then what's the last one? Oh, the length of day is how long?
24 hours.
24 hours. So, here's what I want to have, because like today, that is all that I had planned to do, was walk you through it so you felt comfortable using it. Let me help you out though. This isn't due until Wednesday. I just want to show you, like it's not like I write all the questions ahead of time. I just want to let you know what your week looks like. Tomorrow, when it says the Study Island benchmark, I'm asking you, telling you, your homework is to first of all check your grade. Second of all, make sure you have like headphones or something like that, because it is going to be a quiet working period. You, when you finish your benchmark, if you finish it during class, that's fine. You can keep on working. Your guys, stop shuffling for a sec. Your benchmark, you're still going to have time on Wednesday to work on it. I'm gonna show you some vocab. Thursday, we're taking notes. And then Friday, we're doing a lab, okay? So we got like a whole week of stuff we gotta get through.
What is their people?
I don't know. Alright. So for today, guys, sit down. So, especially the fact that we all have to like leave at this time. So, here's the thing. When you talked about what that whole thing did not show you, if you look at that picture, between the top and the bottom, what could it not show you? All the stuff that was happening where? Under or inside of our Earth. So when you talk about what are the 3 tectonic activities that have changed Earth's surface over time, help me out. What do you call these things that are in our mantle? What kind of cells? Be able to see.
Carbon cells.
Convection, right? So you can say convection cells in the mantle. What are these mountains that erupt?
Okay.
Volcanic action. And what do you call it when we sugar? And earthquakes. So to answer this, you can say the 3 things that have changed our Earth are convection cells in the mantle, volcanic activity on the surface, and earthquakes on our plate boundaries. I will tell you, if you turned in something, what day is today? If you turned in something over